let's do a little torque balancing. 150 grams over here, and that will be 25 centimeters from that point of rotation. Where should we apply 250 grams so that it will be balanced? What is this distance going to be? How do we do that? We need to make sure that the torque that rotates this thing to the left and the torque that rotates this thing to the right, if it's going to be balanced, tell me about those two torques. If it's going to be balanced, the torque on the left and the torque on the right have to balance each other out. They have to be equal. Think about a seesaw. If you've got two kids playing on a seesaw, if we put a big child over here on the left, let's just get some very round numbers, we don't know what the units are, and this one is 2, and we put the little child over here on the right, and this one is 1, if they are the same distance from the center, then this one on the left applies a lot more torque, right? This one on the right can't apply that much torque. So if these two children are going to enjoy the teeter-totter, enjoy the seesaw, where should they sit in order to balance the torques out? If this one has twice the force on the left, this one has half the force on the right, where should they sit relative to each other? Move this one more towards the middle. So, in other words, a bigger force but a smaller distance can balance out a smaller force but a bigger distance. And it's exactly proportional. This one on the left has twice as much force, therefore the distance should be half. This one on the right has half as much force, therefore the distance should be twice. How do you calculate torque? So that'll be the force on the left and the distance on the left. This one will be the force on the right and the distance on the right, and those two have to be equal. How do you calculate a force? Well, this is going to be the force with which gravity is pulling it down, otherwise known as weight. How do you calculate the weight of an object? So the mass on the left, the acceleration of gravity, the distance on the left, the mass on the right, the acceleration of gravity, and the distance on the right. We can get rid of those. Those are on both sides. The reason I wanted to take that step is because if we just went from here to here, or if we just went from the force to the mass, you'd say, Mr. Galiski, that doesn't make sense. You can't just substitute a mass for a force. So now we're done. Because we know this mass, we know how far away it is. We know this mass, we're looking for how far away it is. So the distance on the right is the mass times the distance on the left divided by the mass on the right. Plug those in and let's see what we get. 150, 25, and 250. These masses are proportional, therefore these distances are going to be proportional. Inversely, that is. The mass goes down, the distance goes up. The distance goes down, the mass goes up. What if we have 150 grams, 25 centimeters from the center, and then I'm going to put another one, here's the center, this one is going to be 10 centimeters. How much mass should that be? Catching up, torque on the left and the torque on the right. We do know, though, that the acceleration of gravity is going to cancel out. So we can just say the mass on the left, the distance on the left, the mass on the right, the distance on the right. But this time we are looking for the mass on the right, not the distance on the right. So that mass is going to be equal to this torque divided by that distance. And we had 150 at 25 divided by 10 equals 375